All right, good morning, everyone. Welcome back to Math 154, Week 4, Lecture 2, February 7th. Whiteboard up here as usual before we get into our lecture on 2.2, the weighted average. Reminder, make an addition or multiplication table on your own, not something you're going to turn in. That'll help you prepare for the Excel BMI because you'll need fixed cell references, and it's something that you have to get used to. Even I had to get used to it when I first learned how to do fixed cell references. Everyone does. My math lab homeworks that are due, 2.1 is due on the 9th, 2.2 is due on the 14th. Was there one due today as well? No, right, okay. Excel homeworks, the 1.3 TV loan, that's due today. And then we had warned you that the 1.8 BMI was going to be coming up soon for its weekly due date, and here it is. It's going to be due on the 14th, the one that you should make an addition or multiplication table to prepare for. If you don't want to know what I'm talking about, it means you need to be watching the lectures. We talked about it. We showed you how to do it several classes ago, so please go and find that. We also assigned video quiz 1 last time in Canvas. That's going to be due on the 9th. So if you don't know what I'm talking about there, go back and watch last lecture from the 2nd. Well, we showed that in the introduction where the videos are, where the quiz itself is, where you submit it. We said that you can type your answers, you can write your answers, you can write it on a fresh piece of paper, you can write it on the piece of, or the file with the questions itself. I don't care, as long as the answers are in your own words and complete. Make sure your name is in there as well, just to be safe, but if it's not, it should be fine because it's auto-uploaded in Canvas to your name, so it wouldn't be the end of the world. I will be grading those myself, and I don't necessarily grade them on the 9th to the 10th, because if I have a couple students that haven't turned them in and they have legit excuses like they've had COVID or something, and they have doctor's notes or just documentation for whatever it might be, I don't grade things until I have all students' grades or work in. So that's what the holdup can be sometimes if you don't get a grade back immediately, because I don't want to give students grades while other people still haven't done an assignment. What else? On the weighted average stuff that we're going to be talking about today, this is where I said eventually I was going to give you a file that would help you keep track of your grade throughout the semester. And this is the section where we'll be talking about that. So within the next 2, 3, 4, 5 days, I will either email you or put it up in Canvas. I think I'm going to put it up in Canvas. I think that's what I've been doing the past couple semesters. Sorry, I was preparing for class at the very last second due to something going on this morning. So I'm going to have that in Canvas for you to grab. But I will talk about that next class and show you where it is and all that stuff. But for now, let's not waste any time. Let's go ahead and talk about this very, very important formula that you will have to memorize. It's one of the few non-simple formulas I make you memorize. And even then, it's a simple formula, but it can look crazier when you have more and more and more elements to it. But it is still just the same idea. A couple of additions and a couple of multiplications. That's all it really is. And a division. All right, let's get it.
Let's move on to 2.2, weighted averages. So I've had a couple people at this point, which is pretty typical, email me asking about their grade because my math lab is a pain and doesn't display the zeros that you've earned if you didn't actually open an assignment. So it might say you've got 100 when really you've got like a 10 because you only did 1 out of the 20 homeworks maybe by the end of the semester. But unfortunately, all your grades aren't in my math lab. You've got grades that are in Canvas and things like that. They're in 2 different locations. Canvas will have these ghost assignments, which I've had like 2,000 emails about, and I'm hardly exaggerating. Hey, why does it say this? When is it due? Everybody's panicking because they think they've got assignments that they missed. And no, it's just placeholders. So things like that can screw up a grade book too. So when you ask me what is my grade in a quantitative reasoning course where we're supposed to, the moral, whatever you call it, teach a person to fish and they can eat for the rest of their life instead of just giving them a fish, that kind of idea. So I will never, ever, 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 ever tell you your grade in this course. You, the quantitative reasoning student, are responsible for figuring that out yourself, and we are going to teach you how to do that today. with something known as the weighted average. Now, this technique can be used to calculate your grade in pretty much any course, as long as you have a teacher that uses a weighted system, which there are very, very few teachers that don't. And even the teachers that might say, like, all right, we have 1,000 points throughout the semester, and your tests are worth 400 points, and your quizzes are worth 100 points. That's still a weighted scale. It's just everything's been scaled to 1,000 instead of 100, so that 400 points for your tests is really 40%, 400 out of 1,000. And we'll get into all that stuff later on how we scale things, which we've already kind of introduced with proportions and ratios. But for this class, I've told you my math lab homework is 15%, your quiz is 15%, Excel homework 15%, projects 5%, participation 10%, midterm 20%, final 20%. Where can you find this? In the Yes, You're Right syllabus. So a weighted average is when someone says or something says, this item A is more important than item B, so we're going to give it more weight. And more weight means that it has more effect. So if you earn, say, let's say you have a teacher that just weighs everything exactly the same, and you get an 80 on the midterm and an 8 and a 100 on the final, and everything's weighted the same, you'd end up with a 90 based on the old school average, which is just add up the data and divide by the number of data. Also, I give you the technical name here, which is a mean, because the term average, there's three types of averages. You have the mean, the median, and the mode. Median being the middle entry, mode being the most common entry. But we usually stick to the mean for averages. Notice I said usually, not always. When we like to talk about things like the average salary of an American, the mean and the median give two very different answers. And in fact, most people with an educated background would agree that the median in that instance is better, and we'll get into that another day. So the old school average is just add up all the data and divide. But so if you had an 80 on a test and 100 on a test, you'd get 80 plus 100 divided by 2, and you'd get 180 over 2, which is 90. So your grade would be a 90%, which would be an A. That's the old school average. But a weighted average is where we say, well, this category is more important. The test is worth 20%, and the homework's 15%, and the project's 5%. Those are weights. Weights are assigned values that tell you how important they are. And the larger the value, the larger the weight, the more important they are, the more that they will sway that average, that weighted average. So when we're doing weighted averages, you can do them kind of like I just did up here, but again, this is not a weighted average. The formula is peeking its head down below. We'll get to that in a second. But you can do it by hand, as we'll do several of today. But you could also make Excel do all of your work for you. So this can be used to get your, I'm sorry, I'm jumping the gun here. This old school average, pardon me there. I forgot to read this line. I saw Excel and I got excited. The old school average can be used just to calculate your Excel averages. So we've got 2 Excel grades right now currently, not 3, only 2, because we've only done heart rate and what was it called? The TV limb. Remember that chapter 0 file did not count as an Excel file. That was a participation grade because you literally just copy pasted. You didn't have to do any thinking or creating. It was just watching and repeating. That's a different type of assignment. So you could take your 2 Excel grades right now, add them up and divide by 2, and that will give you your Excel homework average. You've got like what? How many are officially? Oh.
All right, at this point, I kind of stumbled trying to remember how many my math lab homeworks there were, and at this point, it's 3, 1.1, 1.2, and 1.3, which means that you could add up those 3 and then divide by 3. So if you had an 80, a 90, and 100 on those 3 homeworks, you'd add 80 plus 90 plus 100, and then you would be set. I just got to pick up the right spot.
I had said the My Math Lab homeworks, you add 10 points to if they're a 90 or lower, or you make them a 100 if if they were higher than a 90. So a 95 goes up to a 100, 90 would turn into 100, so nothing over 100. So yes, when you create your own gradebook, which I'll kind of show you a skeleton next class. I think I'm going to do it next class because I started building this morning and I'm not quite done. I don't know if I want to show the unfinished product yet. Maybe I will. Maybe I will. So no, you're not rounding your Excel averages or anything like that. The Excel grades are the Excel grades. It's the My Math Lab grades that you could have up to 10 points out of 2. Now, if you get a 0, you don't add 10 points to that. You didn't do anything. I'm not giving you 10 points for free. And then your quizzes, like I said, I think we've had 2 thus far, although 1 is due tonight. Now you might say, well, Mr. Beckner, the syllabus quiz you gave us was out of 4 points. Does that mean if I got a 4, that's a 4%? I got a 4 out of 100? That sounds awful. I got everything right. Why did I get a 4? Well, no, silly. That's a scaled grade. It's 4 out of 4, which would be 100. If you got a 3, 3 out of 4 would be a 75. A 2 out of 4 would be a 50. You just do the division and scale it to a percent. If you got a 3.5, you take 3.5 divided by 4, move the decimal twice, boom, there's your actual grade. So don't let those confuse you. Don't write your syllabus quiz as a 4 or a 5 or whatever it might be. Scale it to a 100 so that everything is in the same measure. So you'll have to do that on your own, or again, you can have Excel do that. And you know what, I am going to go ahead and show you what I started. So this is something I've made as a project before. Honestly, people do quite terrible at it. I'm not going to make it the project this semester. I'm just going to show you what it can look like. So again, this is started. This is not finished. I did this in about 3 minutes while setting up for class. So I've got a column for all my different My Math Lab homeworks, and this is not a big enough column because we're going to go through chapters 9 and 10. Maybe not 10, but you'll need to have the spaces there. You'll have a column for your Excel grades. This is more than we need, but that's okay. A column for your quizzes, also more than you'll need. Your participation grade, which, I mean, if you've been participating, you've got a 100. If you haven't done a single thing, then you've got a 0. So remember to participate. Project grade, blank, we don't have any yet. Midterm, no final. So those all should have nothing in them, but you could definitely have 100 for your participation. So maybe I got a, not a 50. Let's go with a 81 on my math lab homework 1.1. That was really hard to say with all those my's. So I got a 71. I made an 81 in my gradebook. Then in 1.2, I got a 95. So I write a 100 in my gradebook. 1.3, I got an 89. So I write a 99 in my gradebook. Now what I can do down here at the bottom is, after all of them, and again, you might need more columns. So in fact, let me just paint more of these. Wait, that was weird. I didn't mean to do that. Paint more of these. Fill the grids just for fun. I said fill the grids, you silly goose. And then down here, I'll have AVG for average, and I can go equals average, open parentheses. So this is kind of like sum, it's a built-in function. And then I can just highlight all of these. I don't just highlight the ones I've got, because then when I put a grade in for 1.3, it won't be considered in for the average. So you just highlight all of them. And again, I might need more rows than that. I think I need like 2 or 3 more rows than that technically, but good enough for government work for now. So I can see my average is a 90.5 in that column. And then my Excel grades, maybe I got a 10 on the first one because I didn't want to do it, or I just did one tiny little thing. But then I said, well, I can't do this all semester. I got to get my act together. And I got a 91 on the TV loan. And then I get a, I don't know, an 87 on the BMI. Big improvement. And then down here, average, I'll keep it the same abbreviation, AVG equals average. Open parentheses, highlight all of the cells for all of the grades now and future. So my average is a 62, and as I keep making better and better grades, you'll see that get better. So let's say on the next one, don't remember the name, but I get a 99 on it, average goes up. Next one, I get a 100, average goes up. Next one, I get a, I don't know, 85, it was a tougher one. Average still goes up. And then my quizzes. I get a 100 on the first one, I get a 75 on the second one, whatever. And then you can have the average down here. I've already shown you how to kind of set that up. And then somewhere else, I'll have to show you the formula another day because it's just, we haven't gotten to it yet. I have my weights over here, so I'll be using references on those. And we'll come back to that. So what's this weighted average formula look like? It looks like this. Your weighted average, not just an old school average, your weighted average. So a regular average is just add up a bunch of things and divide by the number of things. The sum of weights is technically the number of things. It might not feel like it, but it is. It's as close to being related as it can. So what's going on with this formula? There's this dot, dot, dot at the end. Does that mean it's unfinished? No, it's finished. So it's weight 1 times data 1. So what I mean by weight and data, so let's talk about maybe this 1 is the My Math Lab homework section. So the weight would be the 15%, because that's what your My Math Lab grades are worth, 15% of the total grade, and then times whatever you got for your My Math Lab average. So right now, looking back at that Excel file, my Math Lab average was a 95. So then I could do a times 90.5. And then weight 2, this could be the Excel bit. So you would have your 15% times whatever grade you had for your Excel average, which was this 78.7, we'll round it. So 78.7. And then plus, and then you'd have the quiz section, then the participation, midterm, final, project, all that different stuff for your grade in this course. So it's how much it's valued at times what you actually earned for that section. Or if it's not talking about averages of a grade, it might just be a cost of something, as we'll get into with our examples. So the top is the weight times the grade, or weight times the data, weight times data, plus weight times data, plus weight times data. So it's you're multiplying a weight and a data, and then adding, and then the next weight times data, and then adding the next weight times data, and then adding the next weight times data. This is known as a sum product because you're adding up a bunch of products. The bottom is the sum of the weights. So this would be like your 15% plus the 15% plus the 5%, et cetera, et cetera, et cetera. All the different categories of grades that we just related to. But one small issue is you're generally going to be responsible for identifying which is the data and which is the weights. Now, I just explained for a grading system, the weight is the percentage that's set up in a syllabus, for instance, and then the data is the grade you earn. And then this pair of sentences is just, or triplicate of sentences, I suppose, is just explaining everything I just said out loud. The top is adding a bunch of weight times datas. The bottom is just adding the weights. Sometimes the bottom is 101, sometimes it isn't, and that's when we're talking about grades. If the class is completed, if you've accounted for all categories, then the bottom, you'd be adding up all 100% of your different grades. Or 1 if you're doing it as decimals instead of percentages. That's what I mean by that. But if you're not talking about a grade system, the bottom can be what the heck ever it wants to be. So this is your formula. You have got to memorize this idea, this formula. I will not give this to you on a test. This is a fact of life. I know my Z's look a little weird because I put a line between them. Kind of a British thing, I think. Or at least I learned it from my British teacher in college. So maybe there's an assumption there that's wrong. Either way, not the point of the problem. Weight times data plus weight times data plus weight times data plus weight times data. So we're going to do several examples of this. We're going to start with something much simpler than our grade in this course. And one last sentence before getting into the example down here. Oh, and I left all that stuff. I'll have to erase some things so I don't just show you all the math at once. But when we're talking about grades, your weight is typically what a grade is worth, not the grade itself. Again, the grade itself is what you earn. What the grade is worth is me saying it's 15%, it's 5%, it's 20%. When you're talking about items being purchased, it tends to be the number of things purchased because the more you buy, the more weight that category will have. All right. So our first example, before we get into the guided worksheets, so this is just a random example I have made up. So say we've got a class where you have the following weights, only 3 categories, much simpler than quantitative reasoning in terms of layout, right? So we have 50%, sorry for that, I just dropped my book on my desk. You've got 50% for your homework, 25% for your midterm, and 25% for your final. So those are our weights. 3 categories. I'm not saying there's only one homework assignment. That's you find your homework average, and then that grade counts as 50% of your grade. You don't apply that 50% to every single individual homework grade. That would be extremely tedious. You just do the regular average, and then you apply the 50%, as we'll see. And yes, I think I meant to say that, but the reason I put the line through my Z's is so they don't look like 2's. That is exactly why I do that, because I have terrible handwriting, and it's worked for me for 20 years. All right, so 50%, 25%, 25%. So currently, this is important. Currently, oh, you know what? I don't want to do this example yet. This is the hard one. Darn it. Let me make a side example for this. So I'm going to copy the first part. That is a much harder example that we'll do later. Currently, you have an 80 on the homework and a 78 on the midterm. What is your current average? There we go. That other one, I forgot that last little bit was an extended concept. We'll circle back to that at the end. So your weights are still the same, 50% homework, so that's half your grade, then 25% for the midterm, 25% for the final. Currently, you have an 80 average on all your homework. So I'm not saying you have an 80 on just 1 or 2 homeworks. I'm saying you have 100s and 95s and 72s. You add them all up, divide by the number of homeworks, you got an 80 as your average. And you earned a 78 on the midterm. So these grades are pretty close to each other. What is your current average? Now, we're not just adding 80 and 78 and dividing by 2, because this is a weighted system. We have to account for that. So our weighted average. First, it's important to note what the weights and what the data are. The 80 and the 78, these are our datas. These are the things that we earned. These, I mean, I literally say that they're the weights, so I don't think I need to write that again, but these were how much each category weighs, how much it counts for. The larger the number, the more it counts for. So your weighted average is big old division, where it goes weight 1 times data 1 plus weight 2 times data 2, and you just do that for all of the different categories. So if this was a completed course, notice I said if, I'd have 3 of these. I'd have weight 1 times the homework grade, then the midterm weight times the midterm grade, then plus the final grade times the final weight. I said those last 2 in the opposite order, but it doesn't matter. But there's no final. I didn't say what we have on the final exam. So when things are missing, you need to skip the missing grades. So I'm not going to have 3 sum products in the top. I'm only going to have 2. I'll have the 50% times, so that's the homework category, so times the homework grade, which was an 80, then plus. I'll have the midterm, which was 25%, times the midterm grade, which was a 78. I don't have anything for the final because we don't know what the final grade is. It hasn't been weighed in yet. That's another important aspect of a weighted system. If something hasn't happened yet, it doesn't get weighed in. So I don't have plus 25% times, well, what grade would we have? A 0, a 5, 100? It would be a variable, and spoilers, that's what's going into the next bit, but we won't come to that yet. It's going to be a while. So weight times data, and then we stop because there's no more completed weights. So in the bottom, it's the sum of the weights that we used. It's not going to be 50 plus 25 plus 25. It's only the ones we use. So 50% plus 25%. So again, I don't count the 25% of the final because the final hasn't happened. Now you might say, well, Mr. Beckner, all of the homeworks haven't happened. That doesn't matter. As long as you have at least 1 homework grade, you have a homework average, then you do include the homework bits. So even though the homeworks have not all been completed for the semester, we still count that 80 average as 50% of the grade. That's how we're able to calculate grades before the end of the semester. That's how you will be able to calculate your grades before the end of the semester. All right, so we're going to do all the math here. Pull out our calculator. So we got 50%. I'm not going to write the percentage in this because I can't. So 50 times 80. And then we can just drop the percent symbol for reasons in this instance. So that's going to be 4,000. The 25 times the 78 is going to give us 1950. Let me do this. Perfect. Oops. I say that a lot in here, don't I? Weighted average. So that'd be 4,000. That was the 50 times the 80. Plus the 25 times the 78 is 1950. Over 50 plus 25 would be 75. I'm not showing that in my calculator. 4,000 plus 1950, that would be 5,950. Divided by 75. So let's do that division. 5,950 divided by 75. And we get 79.3. And then it's 0.33333. I could write 0.33 if I wanted to, or 0.3 or 0.3 bar, whatever my math lab tells you to round to if this was an actual assignment. In terms of your actual grade, we know teachers only deal with the whole numbers, so your grade would be a 79. So that's our weighted average. And then you can ask yourself, does this make sense? Like you're supposed to do after every single problem in this course. All right, so we had an 80 on our homeworks and a 78 on our midterms. Well, a 79, I feel like makes sense because it's somewhere between these two. If I calculated my average and it came out to be a 33, that would not make sense because I don't have any grades even close to that zone. I don't know why I was saying remarkably close. Relatively close, whatever R word I was going for. If I have grades of 80 and 78 and I calculated my average to be a 95, that would not make sense. So your weighted average needs to be somewhere between the numbers given. On top of that, when you only have a couple categories, you can actually tell which one it should lean towards. Since the homework counts as more of the weight, it counts as more of your grade, it has more importance, so to say, then the average should lean more towards whatever the homework is. So with an 80 and a 78, this has more importance. So that means the average should be closer to 80 than 78. And before you rounded, 79.33 was a little closer. Now, when you've got a whole bunch of different categories, it can be quite difficult to confirm that it's closest to the right one, especially if your grades are varying wildly. These did not vary wildly. But again, the make sense aspect really helps in terms of if you got an answer of, say, 45 here, or 71 here, or 95 here. None of those would make sense because they're not even in between all the grades given. So this is the most important aspect of a weighted average for you, the student, but there's still important aspects to weighted averages in the real world that you can take once you're not students anymore. Scrolling, scrolling, scrolling. Such a long section. So I just want to kind of peek at the intro to this 2.2 section. Weighted average, you could just write your formula there if you wanted to. So what they have here is they're talking about tuition, fees, room and board, all that jazz for the 3 different categories of schools we talked about before. And these are enrollment weighted, which means if one of these, if any school has more enrollment, then their number would have more value. So like a school of 20,000 students, if they cost $10,000 a year, and then you've got a school with 100 students and they cost $1 million a year, the value would be a lot closer to the first one because there's 20,000 students versus 100 students. So 20,000 students would be the weight. There's a lot more, so it would say that number is a lot closer. Now, that million number was a little redonkulous and could have an ugly effect, but you get the idea. So that's how these numbers were acquired. And they say, take a moment to think about what this might mean. If they simply list tuition, fees, room and board for all schools and take the arithmetic average, which means add them up and divide by the total number of schools, they don't take into account the fact that, oh, there's only 2,000 students at Bowdoin, I don't know how to pronounce that. This has been at least 3 semesters of laughing at that. And they were paying 80,000, while some other school had 30,000 students, which was like 15 times as many. and they were only paying 20,000. So maybe these are two private schools, but one of them is just, I'm going to say that fun word again, redonkulously overpriced, and that's why there's only 2,000 people going to it. Whereas the one that's a little more moderately priced, at least for private school, that's why there's 30,000 private students. Well, obviously this isn't a private school, but I'm just trying to get a point across. Because this isn't just tuition, it's room and board and all that stuff. And 2017, tuition got expensive in the 2000s, as you know. So if you just average the $20,000, the $80,000 from those two schools, excuse me, you get 50,000. 20 plus 80 is 100. 100 divided by 2 is 50. So 50,000 would be the average. But that's not representing the fact that there were way more students paying 20 grand than there were paying 80 grand. So it's a lot better to take that into consideration and weigh it. So that's what this does. They say, all right, the 2,000 students, that would be the weight from the smaller school, and they were paying 80,000. So 2,000 times 80,000 is kind of like our grade percentage times the grade we earned, then plus. And then the next weight is there's 30,000 students there times the cost they paid of 20 grand. And then the denominator is supposed to be the sum of the weights, not 80,000 plus 20,000. This is where you might make mistakes initially. So if you did 80,000 plus 20,000, you get 100,000, and ultimately you'd get an answer that wouldn't make sense. So the weights, the number of students is what makes them, the prices tend more towards them in the average. So 2,000 plus 30,000. You do the math, you end up with 23,000. So because there were a ton more, 15 times as many more students at Austin versus Bowdoin, the B school, because there were way more students, that average is a lot closer to what they're paying than what the other people are paying. So that's where these numbers came from, is what they were saying above. They were enrollment weighted. So this actual public four-year school number of 19,000 takes into fact all these different schools with all these different enrollments, does a giant weighted average, and they came up with this number, which has to mean there's a lot of schools out there that are cheaper and with a solid amount of students as well. But I mean, who's paying $80,000 for a public school? That just seems weird. But I mean, it was just the point of the problem. All right, so guided activity 1, we're gonna complete this together. They sit the weighted average formula in front of you again, and I will remind you one more time. This has to be memorized. It's not like you're memorizing some giant formula. It's more of a concept, because I could say you need to memorize it this way. It's weight 1 times data 1 plus weight 2 times data 2 plus weight 3 times data 3 plus weight 4 times data 4 plus weight 5 times data. I can make this formula gigantic, and then of course over the sum of the weights. Weight 1 plus weight 2, etc., etc. It's a lot better to memorize this as a concept. Conceptually, it means some product at the top, weight times data plus weight times data plus weight times data until you exhaust them. That's what these little ends mean until it's done. Then the bottom is just the sum of the weights, but you got to make sure you're adding the correct values. So number 1, you buy 8 children's tickets at $5 a piece and 2 adult tickets at $12 a piece. I'm just going to keep the annotation on this screen. You're going to have to deal with slightly ugly handwriting for a few minutes. Sorry. What is the average price per ticket? Now you might say, oh, well, just 5 plus 12 is 17. 17 divided by 2 is 850. 850 is the average price per ticket. No, because they're talking about what was the average price you paid. So you'll end up buying 10 tickets total, and you want to know across those 10 tickets, what was the average price? So if you just took that number and multiplied it by 10, you'd get your total cost. That's how averages work. But because of the variability in cost, kind of like the variability in our grade weights, you have to do a weighted average. So I would actually answer question B first if you want to be technical about this. But what I'm going to do is, you guessed it, I'm going to do it wrong first, because that's what we like to do sometimes, so that we can say, does it make sense, and have it not make sense. All right, so weight times data plus weight times data. So maybe the 8 and the 2, the number of tickets are the weights, or maybe the 5 and the 12 is the weight. So this red is going to be for wrong. Let's say I say it's the $5 and the $12, that's the weights, weight 2, excuse me. And then the 8 and the 2, those would be the data, so D1 and D2. So I would say this weighted average, weight times data. For the children, you've got the weight was $5 times the number of tickets, which was 8. Again, this is wrong. Plus, then I said weight 2 was the $12 times the number of adult tickets, which is 2. So this is the children, this is the adults. Don't mix and match. Divided by the sum of the weights. So in this instance, I said 5 plus 12. 5 times 8 is 40. 12 times 2 is 24. 5 plus 12 is 17. 40 plus 24 is going to be 64. And 64 divided by 17, I can't pull up my calculator right now without taking an extra 2 minutes, so I'm doing this on my own. You get 3.76. Does it make sense? What is the average price per ticket? $3.76? What? No, that doesn't make sense. Some of the tickets cost $5 and some of the tickets cost $12. In no world does this make sense. How is the average cheaper than the cheapest ticket you bought? So that tells us if you didn't goof the math, which we didn't, that means you goofed up what you assigned datas and weights. We flip-flopped them. So let's clear our screen and let's do it right now. Remember, if I'm moving too fast, pull up the YouTube later and pause. Weighted average. So it's really that the number of tickets purchased are the weights. So that's the first one and the second one. And the ticket prices are going to be what we call the data. And I understand that it feels like the cost could be the weights. I understand that at first glance, but that's why I specifically am doing this problem for us, because it's actually the number of tickets. It's easy to get this confused. This is the thing that when we roll up, we can have an effect on. And that's not actually the typical thing, because with grades, the thing we have an effect on is the grade earned. We can't affect the price here, so it feels like it would be the weight in that regard, because we couldn't affect the 15% or the 20% with our grade. But it's a little flip-flop there. All right, so weight times data, so that's for the children, 8 times 5, plus for the adults, 2 times 12, over the sum of the weights, which is 8 plus 2, right? Yes, 8 times 5 is still 40, 2 times 12 is still 24. See, the top actually doesn't change at all. The 40 plus the 24 is still going to be 64, but the bottom changes drastically to 10, and 64 divided by 10 is $6.40. And yes, that does make sense, because this value is between the two different prices we're paying. 640 is between 5 and 12. In an extended, does it make sense? And I'll say yes, it does. We bought more children's tickets, so the average should be closer to the children tickets price. If I flip the 8 and the 2, if I bought 8 adult tickets and 2 children tickets, I would expect this average to probably be like $10.50, or somewhere in that ballpark, plus or minus 50 cents. I would expect the adult tickets to govern more if we bought 8 of those, so the average would be closer to its $12. Now, again, if I've got all sorts of categories, if there's military tickets for $7.50 and student tickets for $8 and senior tickets for $3.50 and babies get in for $1, then it becomes a little more saturated and difficult to tell if that number makes sense. And you just got to hope that you've practiced enough to get it right. So what were the actual weights in this problem? It was the number of tickets. On time, 40 minutes, okay. And, I'm not scrolled down enough. Well, I can do the work for A. So for number two has the exact same question. What are the weights? So where can I do that? I'll put it up here. 2B, what are the weights? So I have drastically spoiled this already, and I'm going to answer 2B first because I think it's important to answer the weights before you do the math, assuming that you can get everything correct. Alternatively, you do the math on a simple problem. If the answer doesn't make sense, your weights are probably wrong, or you could have just goofed in your calculator. Remember, your calculator is not perfect, especially if you don't know your calculator. So your grade consists of a test worth 80% and a paper worth 20%. We got a 70 on the test and 100 on the paper. This course is completed. It was a very simple course. Test 80%, paper 20%, not even remotely close to QR, right? We got a 70 on the test and 100 on the paper. So part B, what are the weights for this? It's obviously the 80% and the 20%, what the teacher assigns as the quite literal weight of the grade, the percentage that it counts as. All right, so what grade do we get in the course? Well, we got to do the formula, weighted average. So the weights are the 80% and the 20%. We just got to stack the 70 and the 100 with them appropriately. So weight times data plus weight times data, and that's going to be it. There's only two categories. The first weight for the test is 80% times its data. We got a 70 on the test, not a 100, a 70. Plus the paper was worth 20%, that's its weight, times the data is what we actually earned, which is 100. Don't forget to divide by the sum of the weights, which was 80% plus 20%. 8 times 7 is 56, so that's going to be 5,600. 2 times 1 is 2, so we're going to just stack our zeros. Sorry, my dog is distracting me. He's borking. 2,000 over, and then 80 plus 20 is 100. Now, some of you might be saying, well, instead of writing 80%, 20%, can I write 0.8 and 0.2? Because that would be the decimal equivalents. Absolutely, you can, as long as you're consistent. If you do percents in the top, you better do percents in the bottom. If you do decimals in the top, you better do decimals in the bottom. I'm going to have to go over here. Sorry, I don't know why I didn't put the weighted average over there. So the weighted average, 56 and 2,000 is going to be 7,600 divided by 100. That's really easy to do without a calculator. Just cancel the zeros, and you get a 76. Does that make sense? Well, again, with only two categories, we can definitely confirm if it makes sense or not. Because the test is worth so much more, our grade should lean closer to the test grade. 70 on the test, 100 on the paper. It would be awesome if they were worth the same and we got an 85, but no, the test is worth way more, so the grade is going to be a lot closer to the 70 than the 100, and 76 is definitely closer to 70 than 100. So yes, it makes sense. All right, I wish I didn't have to clear the whole screen, but I'm gonna, because the next question is gonna relate to that. So really quickly, I'm just gonna 80% times the 70 plus the 20% times the 100 over the 80% plus 20%, we got a 76 as our grade. I just want that up there. And I still didn't give myself enough room. Dang it. There we go. Sorry for that. This is why I don't like using this mode. It was 80% times 70 plus 20% times 100. And I can't even read these numbers anymore. Now I have a bar covering that for me. 80% plus 20% equals we got a 76. Okay. Now we're in question 3. Now assume there are 2 exams worth 40% each and a paper worth 20%. I just wanted that completed for while we're working on 3. You get a 60 on the midterm and 100 on the paper. What is your grade at this point in the course? This is what I was talking about a lot earlier relating to your grade. We haven't done a midterm, we haven't done a final, we haven't done a project. So 45% of our grade isn't even being weighed in yet. You don't use weights that aren't being weighed in yet, that you don't have grades for yet, so to say. Now be careful, it's 2 exams worth 40% each. So exam 1 counts as 40%, exam 2 counts as 40%, and then The paper is the final 20%. So the 60 on the midterm is not 2 tests, it's just one of them. Oh, this dog, he's funny. Distractions. So we only have one exam so far. So we're not going to have 40 in there twice, we're only going to have it once. So our current weighted average with just these 2 grades, it's going to be the 40% for the midterm times what we got on it, which is a 60, plus we don't do the 40% for the final because we don't have a grade yet, and then it's the 20% for the paper times the 100 we earned, divided by. Do not add up all percentages, just the ones in this formula. The 40% for the midterm, which we have a grade for, plus the 20% for the paper, which we have a grade for. No grade on the final, don't put it in the weighted average. 6 times 4 is 24, so that's going to be 2,400. 2 times 1 is 2, so that's going to be 2,000 over 60. The top is going to become 4,400 divided by 60. That's a terrible looking 6, isn't it? And if you do that division, you end up with 73.3. And again, you could round to the nearest whole number because that's what your teacher's going to do anyways and call it a 73, but I'm just going to stop there. Does it make sense? Well, the exam counts for more than the paper, so yes, your grade should be closer to the midterm grade. So an 80 would be just splitting the difference of 60 and 100 if you added 60 and 100 and divided by 2. But there's weights here. All right, I got to stop my dog. He is extremely distracting. Give me 20 seconds. All right, I'm back. B. So A is like we're halfway through this. Are you serious? He stopped for all of 2 seconds. Okay, I'm just going to try and not be distracted. Good luck to me. So A was like we're part of the way through the semester, kind of like we are right now with quantitative reasoning, kind of like we are with most courses. B, now we're going to think about, well, at the end of the semester, when we take our final, because we're now just doing these 3 categories, what is the highest grade we could get? So what we're saying is for part B, all the stuff in part A is still in effect. We still have the 60 on the midterm. We still have 100 on the paper. But now we got to say, you know, based on whatever grade on the final exam, what's the highest grade we can get? Well, if you want this to be as high as possible, and this is drastically different from that example you saw in my notes earlier, if you want this grade to be as high as possible, what do you want to earn on the final? You need to assume on the final that you get a, that's right, 100. That would earn you the highest possible grade. Now, maybe you wanted to know what's the lowest possible grade you can get in this class, then you call the final a 0. What that would do is give you a window of where you could end up. Some people like to go, you know, hey, if the final exam is only 10% and I have 100s on everything, do I even need to take the final? Well, technically, in that very, very rare instance, no, because you'd lose that 10% and you'd still have a 90. You'd have an A and you're good to go. So we're going to assign the final as a 100. So now our weighted average is a 40% times the 60 plus the 20% times the 100. Doesn't look like there's a times in there. Plus now the 40% for the final exam times the assumed magical 100 grade, which is extremely hard to earn in a QR class, divided by, now my other dog is scratching himself on my desk and knocking it. Hey, buddy, hey, come on. Okay, so divided by the sum of the different weights, the 40% from the midterm, the 20% for the paper, and the 40% for the final. So we do have everything completed at this point. Yes, LOL indeed. All right, so 40 times, all of the first bits are still the same, so that's 2,400 plus 2,000 plus the 40 times 100 is going to give us 4,000. divided by 40 plus 20 plus 40 is 100. Adding all of those up, that's 4,400, 8,400 divided by 100, cancel the zeros, and you get an 84 as the highest possible grade that you can earn. So what that means is you can't make an A, unfortunately. That midterm you earned a kind of low grade on had too much of an effect already. Now, these tests were weighted very, very heavily. Your QR teacher is a lot nicer, and it's just 20% for each test. Now, we don't get a lot of classes, especially in community college, where your grade has got tests worth 40% each. But if you go to grad school or 400 level classes, you certainly could have that. I know I had a class where the whole grade was a final. That was it. There's no midterm, there's no homework, it was just one final. It was quite terrifying for most everyone. All right, so you can earn a B, but you don't have a lot of wiggle room with this B, do you? So an alternative approach to this, what is the highest grade you can earn? Maybe you just want to say, well, what grade do I have to get on the final exam to earn a B? So what grade is the minimum to get a B? Can I get a 82 in the final? Can I get a 78 on the final? Can I get a 61 on the final? That's going to be a little more of an algebra problem. That's what I had in my own notes. We'll come back to that later, though. We still want to do a little more practice with this idea. Okay. So let's go off of Annotate, scroll down, and here we go. This, ow, it just wheeled over my foot. This is a great day, isn't it? This is going to feel a lot more like our actual course because we got a homework category, a quiz category, projects, midterm, final. So it's missing one column or one category. It doesn't have, actually 2 columns. It doesn't have participation and it doesn't have Excel homework. But again, I'm not saying this is our class, this is some other class. It's just a little more similar. It's similar in some ways that these grades are scaled differently as well. Look at these homework grades, 7, 8, 6, 10, 9. These sound awful, but what that probably means is these homeworks are based on a 10-point scale. If I don't see anything over a 10, I'm going to assume the student isn't doing terrible. I'm going to assume that was a 70, an 80, a 60, a 100, and a 90. Same for the quizzes, a 70, a 90, a 75, and a 78. So that's something to consider with these averages. The average isn't really an 8 and a 7.825. When you think about everything on a 100-point scale, which makes our brains hurt less, this is really an 80, and this is really a 78.25. This is something I've already mentioned is an issue with any grades I post in Canvas because I usually just put the grades based on points. So if there's 4 questions, it's 4 points. If it's 10 questions, it's 10 points. Also, you might see those participation grades, which are often 1 or 2 points. That really isn't supposed to affect your grade at all. They're just 100s, not 1s or 2s. So that is an important aspect to understand here because it mildly relates to you, especially in the Canvas section. So you would need to rescale your averages there. Or rescale the individual grades even because my quizzes are done with all sorts of systems. So you have to say, oh, okay, well, this one was worth 5 points and I got a 4. 4 to 5 is a 80. Or this one was worth 4 and I got a 3. 3 out of 4 is a 75. You just do the division and it gives you the number. That's all it is. All right, so the point of this is, what formula is in cell B16, which is right here where the 8 is. So it's not 8. We want an Excel formula, so equals blah, 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 blah. What is the student's grade in the class right now? And then what will her grade be if she gets 100 on the next project and a 95 on the midterm? I need to pull back just a little bit so I can get all this on here at once. There we go. Let's go to Annotate. What formula is in cell B16, which is right here? Well, it's a formula, so equals. There is a word staring you in the face which tells you exactly which Excel function. This is the average of all the homeworks. This is the average of all of these homework grades. So it's preventing you from having to add up 7 plus 8 plus 6 plus 9 or whatever and dividing by 5. Because then when the next one is, you then divide by 6. So that average is not just applied to these. It is not just applied to what I have circled. It is not just applied to those. because we need to have this formula set up so that when this grade comes in as a 10 and this one comes in as a 2 and this one is a 5.9 or something, that this number changes to a 8.5 and then a 7.8 or whatever it might be. So, average. Don't abbreviate it. This is the word, and we have talked about that one before. We've used sum a lot more, but we do use average here and there. And then you need to take the average of all the important cells. So you're supposed to go the first entry, colon, then the last entry. The first entry is obviously where this 7 is, which is cell B3. Okay. Where does it end? Well, it doesn't end here. It does not stop here, because then it wouldn't account for the rest of these. So it actually has to stop at this cell where we said, all right, we're only going to have up to 12 homeworks. So you got to know how many homeworks are possible in the future. Well, this cell, it's not 12, it's not B12, it's B14. 12 is just us saying, hey, that's the 12th homework. So that's the formula in that cell. What is the student's grade in the class right now? So this is where we switch to our weighted average. Remember, going across a single category is just add them up and divide by the number of them. When you're going across separate categories like now, it's a weighted average. So our weighted average will be, well, let's do the homeworks first. So the homeworks count as 20%, so 20% times the homework grade. Now you don't have to do anything with the 7, 8, 6, 10, and 9. Excel already did it for you. The homework average was an 8, but you don't just write 8. That would be wrong, because all these other grades, this project was a 93. We're going to have a 95 on the midterm later. So let's make everything the traditional 100-point scale. So let's call the 8 an 80 plus. Next, the quizzes. So we'll have 20% for the quizzes times not 7.825, 78.25, and do not round that, plus. Now the only other grade we have thus far is a project, and it's a single project. Notice it says the word each. That is critical. It's not add up all the projects, divide by 5, and then that grade's worth 8%. It's 8% each. So the 93 is 8%. This 95 we'll have later, which is not part of it yet, will be 8%. So we go 8% times the 93, and then we divide by just the weights we've used, which were the homework of 20%, plus the quiz, which was 20%, plus the single project, which was 8%. All right, so 2 times 8 is 16, so that first one is 1600 plus 78.25 times 20 is going to give us 1565, plus the 8 times the 93 is going to give us 744. Confirm those with your own calculator. 20 plus 20 plus 8 is 48. Then adding up the 1600, the 1565, and the 744 is going to give us 3909 divided by the 48. And you'll get 81.43, blah, blah, blah. Let's just call that 81.4. Or an 81 when you round to the nearest whole. Again, I haven't specified how to round. Yes, you know your grades are typically rounded to the nearest whole. And maybe not rounded, maybe something known as truncating, because some teachers are not super nice. If you earn an 89.9, some teachers will go, yeah, that's an A. 89.9, let's round up to 100. But some teachers will say, no, sir, no, ma'am, 89.9, it's a B. So that's known as a truncation, when instead of rounding, you just call it an 89. That's called truncating it. You just delete the decimal. You don't account for it. All right, part C, beefing it up a little. Now we got some more grades. Still not a completed course. We got 100 on the next project. So with part B, now this is 100 and a 95 on the midterm. So again, where this grade is, in Excel, there's a formula here, equals blah, 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 blah. They would calculate it for you as you typed in those grades, and it would do all of that for you. The actual formula you need to account for the blanks and stuff has some if-then statements or using the count function. It's something that's a little above your pay grade, which is why I said I'm going to just kind of set up that formula for you, but you will have to type it out. I will show you exactly what the formula looks like, not today, but you'd have to type it out. Okay, so weighted average. Now we still have all of the stuff from before, the 20% times the 80 plus the 20% times the 78.25, that's homework and quizzes, plus project 1, 8% times 93, plus project 2, 8% times we got a 100, plus the midterm, which was 10% weighted at a 95 grade. All over, so we're still missing 3 projects, we're still missing the final. So this bottom is not going to be 100, it's 20 plus 8 with percents, of course. Sorry for the rushing, getting close to time. Now we also have the extra project, which was another 8%, plus the midterm, which was 10%. Let me do this. This number right here, we already know that was the 3909. That's not going to change. But the 8% times the 100 is going to be 800. The 10% times 95 is just going to be plus 950. Sorry about that right there. Then divided by, the bottom was 48, plus another 8 is 56, plus 10 is 66. So again, that's 3909 plus 800 plus 950. There, that looks a little better. Okay, so when we add, I dropped my calculator, 3909 plus the 800 plus the 950, we should get 5659 divided by the 66, and we'll get an 85.7, which again, your teacher might round up to an 86. They might just call it an 85. In this instance, it wouldn't affect you since it's a B either way. If you were in a plus minus system, it depends on the school. If an 86 is the B plus or if an 87 is the B plus, but we are not on a plus minus system. Makes grading a lot easier. Also, I feel like it makes students freak out a little less. I'm sidetracking, I know. Either way, I'm not going to sidetrack. I'm going to stop. Now you might want to ask yourself, does this make sense? And you might go, well, how am I going to say if it makes sense? There's all sorts of categories. I'm not going to be able to say what this number should be closer to. What you can say in terms of making sense of it here is, did your average from B to C go up or down? And should it have gone up or down? So we went from an 81 to an 85 and some change. Well, the new grades we earned were higher, 100 and a 95. So yes, it makes sense. If we had an average of an 81 or 82, and we then earn 100 on some assignment and a 95 on some assignment, our grade should go up. How much should it go up? It gets difficult to say. It's going to be very hard to make sense of that side of things. But it didn't shoot up to a 100 instantly, so that's a good sign. It didn't just stay right by 81 because 10% of the grade was a 95. That's a pretty large chunk. 8% was 100. That's a large chunk. So it went up a few points. I'd say that's in the realm of sensibility. Now again, Excel can do all of this for you. You don't have to do these hand calculations. You have a formula here. All you gotta do is just input grades, input grades, input grades, and this thing will update as you progress. All of a sudden you put in your final of 200, excuse me. Why did I say 200? I wasn't even close to the number I wanted to say, of an 87. So you put an 87 here, and then all of a sudden your grade would change. It wouldn't become a 200, that's what I was trying to say. It would probably go up maybe a few points or down a few points based on proximity of where your grade was before. All right, so last problem of the day. Back to the notes. The stuff I said was a little more above and beyond what we originally did. So same example from earlier, weights are 50% homework, 25% midterm, 25% final. Currently you have an 80 on the homework and a 78 on the midterm. What grade must you at least make on the final to get a B average? This is a question a lot of people ask themselves, and they might want to ask their teacher, and they'll go, well, I'm not going to calculate that for you. That's more complicated, especially if you have 150 students asking the same question. This involves a little algebra. Everything else we were doing was just arithmetic. This will be algebra because you're going to have an unknown as one of the grades, and the final grade is what's going to be known. So we're going to use the weighted average formula, but we can't assume a number for the final exam. That's what I'm saying for final here. We need to make it a variable, and what I decided to call it is x. That's just a parentheses around it. If you wanted to call it f for final exam, you could. If you want to call it t for I don't know why, but you could. And then we said we want to get an 80 as the ultimate average. So instead of us just crunching down numbers and getting the answer, we set it equal to 80 to achieve this goal. So this is going to look a little different. So let me kind of circle things as I talk about it, since I already have this up and we only have a few more minutes. I would not have time to replicate all of this. So we're setting the weighted average equal to 80. So where I would normally say weighted average equals blah, 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 we'd crunch this down and get a number. We're assuming it's an 80 because that's what we want to get in this class. Obviously, we want an 80 or higher, but an 80 is the minimum, so that's the standard we set to it. If we wanted an A, we would instead set this to a 90. If we wanted a C, we would set this to a 70. We would not set it equal to a 60 or anything less because we don't want D's or F's, right? Right. So what's going on? This 0.5 was the 50% for the homework. And then the 80 was the 80 we already had on it. Then this 25, and I did this as decimals just to mix it up. I mentioned this earlier, so if you don't like writing 0.5, you could instead have written 50% here. You could have written 25% here, and you could have written 25% here. And then this on the bottom would also be 50%, 50%, 25%. You just have to be consistent. All right, so back to where we were. We said the 50% was the homework. The 25% was the midterm, and the midterm grade was the 78, so that's there. But then we're trying to figure out what we need on the final exam, so we are going to include it this time. What do we need on the final? So here's the 25% for the final. We don't know the grade, and that's what we said we had to call it X. Then the bottom is just the sum of the weights, the 50 plus the 25 plus the 25, or 0.5 plus 0.25 plus 0.25. Again, just wanted to do this the different way so you can see it works. Now what we've got here is an equation, and we have to solve this for X, because this is our equation, all of that together. So I want to undo all this circling of things so it doesn't look like a mess. I wish I could have like just a state frozen. That's okay. So that got ugly, didn't it? Just ignore what you're seeing for now. I'm going to show the work. So what we had was the 80 equal to. Now the 0.5 times the 8, well 5 times 8 is 40. So, I'm sorry, 5 times 8 is 40. That would say it's 400, but there's a decimal which makes it 40. Plus the 0.25 times the 78 is 19.5, so 19.5. Plus the 0.25 times x stays that. You don't actually get to multiply that out because it's got a variable in it. Then divided by 0.5 plus 0.25 plus 0.25 is 1. This is another reason I did this problem this way. With this particular setup, it is actually a lot easier if you make the percentage weights the decimals instead of the percents, because otherwise this would be 100%, and you would have to multiply both sides by 100 to clear that fraction. Dividing by 1 is literally just don't write it. So this is 80 equals 40 plus 19.5 plus 0.25x, which 40 plus 19.5, it's going to give us 80 equals 59.5 plus, I did not add the 0.25 because that's not how algebra works, and then we just got an equation we have to solve. this needs to be subtracted, so we subtract 59.5 on both sides. Again, you can use your calculators to confirm these numbers on your own time, but 80 minus 59.5, that's going to be 20.5. I get 20.25 equals 0.25x. Doesn't matter, that's a decimal, just divide both sides by 0.25. Yes, you can multiply both sides by 100 to clear decimals like this, but you don't need to do that because you're using calculators anyways, and you'll get an 82. Oops, wrong color, not that it matters. So 82 is the grade that we need to earn on the final exam at a minimum. If we want to earn a B in this course, we have to at least get an 82. And that's because our grade isn't even an 80 before the final. So yes, we have to make higher than an 80 to actually pull that up. What you might want to do for fun is go back and say, okay, well, what would I need to earn what would I need to earn on the final exam if I want to get an A? So for an A, you'd go 90 equals to, and then the right-hand side is literally the same thing. You'll solve it and you'll get an answer. Now, let's pretend we got 105. Can you actually get an A? If you need to earn a 105 on the final exam, could you actually get an A in this course under the assumption that there's no bonuses, no grades over 100s, which we don't do in QR. Hundreds are hundreds, that's the best you can do. Then you say, no, I can't get an A because I need more points than possible to get that A. So if this grade is ever higher than a 100, that means the grade is not achievable under normal conditions. Now, if you have another professor, not me, who gives grades higher than 100s at this level, then that's them. But we max out at 100 because a lot of things in this course are kind of, they're freebies as long as you put in the effort, but we do expect the effort. All right, we did not get to the discussion board. That's going to be in the next section, so you get off easy on that one.
So yeah, we will start 2.3 next time. Make sure you know the due dates for everything. Like I said, be on the lookout for that grade calculator Excel file to keep track of your own grades all semester. I will not tell you what your average grade is at any point in the semester. Remember, my math lab does not have your average grade. Canvas does not have your average grade. You will have to keep track of that. Remember that whatever grades you have in my math lab, as long as they are a passing grade, you can add 10 points to them, except you can't go over 100. So 95s turn into 100s, 85s turn into 95s, 75s turn into 85s, et cetera, Besides that, don't really have too much to add. Make sure you keep up with your homework. Make sure you read ahead. Make sure you read the notes to share from 2.3, as well as look at the textbook for 2.3 before next class. Remember, the expectations for this class are that you are putting in 6 hours of work outside of just watching the lecture during the live sessions, or the one time whenever you're catching it on YouTube, if that's the case. All right, so have a good one. We will see you on Wednesday. Take care, everybody.